Okay, here's what I found. So I found a little aircraft stainless AN washer here. Here's the washer he had. And here's a little thin nut. It looks like it'll fit in there. Good. If it's too tall, I'd have to cut this thing down. Okay, so I found me an O-ring. See it up in there is an O-ring. So that's off a Tillotson carburetor mixture adjustment screw from 66 to 69 Harley. Jumping away. Alright, so that's the O-ring I found. So it fit tight around the screw. Next thing is going to look for like a McCuney screw or a Kaihin, but I found a Tillotson one and that worked. So we got the chamfer in there. The O-ring will go in there and seal against that. As you can push it down in there, it'll seal up into that. And you shouldn't have to put any sealer on it, but it probably wouldn't hurt to put a little dab of sealer in there just in case, but I'll let him worry about that. So my washer here, I think is a little bit bigger than his washer. Oh yeah, definitely bigger diameter. His I don't think would seal very well. And it probably would just barely cover that chamfer right there, but it'd be close. Wouldn't cover it by much. Yeah, it just barely would work. Mine's a bit bigger, so it works better. Shouldn't be a problem. Now, what I don't know is how deep the seat is in there. And you can see, you can probably see with the camera, but I can't see it. I can see there's a small little hole down there, but I can't tell if it's been spotted with a drill or not. As long as it's on center, it can be spotted with a drill and it'll still seal, because it's just a taper screw hitting a sharp corner, so it digs in on the edge. That's all it takes. Okay, so I'm going to take this O-ring off of here. Don't lose it. It's hard to come by. Go ahead and put the nut on there. Looks like it goes pretty much all the way up, which is good. Definitely can see the washer as mine's bigger. So you can see how much bigger diameter my washer is. And there's a little thin O-ring. It's definitely thin. So it sits right over the hole like that. And it should compress into there a little bit. The other O-ring I found was too big. It was something off a Benelli motorcycle. My dad's old O-rings. Italian stuff. Leftover inventory. So, alright. So I'm going to put the sharp side of the washer down. There's a radius side, a sharp side. That way putting sealer on there to give you more sealing area. So go ahead and put our O-ring up in there. Press it down. It's a nice tight fit on the thread, so it should push in and seal against it. Put a little pressure on that. So I'm definitely putting pressure on the O-ring. Everything's bottomed out, so I don't know if I'm sealing the taper or not. I'm pushing pretty hard at that screw. You can see the O-ring's completely compressed into there. So the problem is that nut's too damn thick. I can't feel the screw bottomed out in the oil pump. I don't want to get too carried away with pressure either because there's not that many threads. Okay, what I'm not seeing is a nice good O-ring, a good line where it's actually hitting. So that's not a good sign. Alright, so we're going to have to take this nut out of here. Appears to be too big. Put it back together with just the O-ring. Screw it in there and see what we got to work with. Okay, it's definitely tight right there. Looks like the nut's just bottoming out at the same time it does inside of here. So nuts needs to be cut down slightly. Not much, but a little bit. It's going to be hard to do that. Now it's all the way in, you can see how the screwdriver slot is straight across, pretty much. I just don't know how deep it is. Once again, I'm not seeing a line down there like I want to see. It's definitely bottoming out against something though. Okay, so this nut needs to be trimmed down. So the first thing I do is hold it in the lathe. Enough that I can do that. So I'm going to use a screw to hold it. Try to figure out what it's going to take to get this to work. Light pressure, not too much. Appears to be pretty even. So that's enough to turn the nut. The nut looks like it's wobbling, but the screw is not too bad on center. Of course, that's free to wobble all over the place. Nuts aren't made too square though, so. Alright, we'll play with that a little bit. It's enough to work. Don't lose that. Seems like it's sharp enough to cut. Try to make it a little bit more square here on the cut. See if I can get that to happen or not. Can't keep track of where the low spot and high spot is. Cheat. We're going to cut it. See where the low spot and high spot is. Put a felt tip mark on it so you can see where you're at. Until you just touch. See the mark I cut. Right there on top. like the same spot again. Still looks way out of whack. I don't know how much I'm really hitting it, so. I'm doing the same thing every time. Number 3. Screws wobbling around more. Had it pretty much dead nuts on when it started, now it's way off. So. The nut looks better, but the screw looks worse. Keep cutting more off the top of the screw. That's the high spot of the screw. Which is exactly where I've been cutting on it. See? Yep, 3 and 4. 3 is where I was at, so it's between 3 and 4 right here was the screw's high spot. Problem is I can't get in to measure because I can't get a caliper in there. It looks like the nut might not be very flat. Well, if I keep doing what I'm doing, I'm going to make it worse, not better, which I don't want to do. Alright, so we'll call that a failure. I'm going to measure the nut and see how accurate the nut is. If you don't fully check your merchandise before you start modifying, you don't know what you're doing. 119, 124. What a shocker, the low spot's the part I've been cutting on. Wonderful. Yep. Fight thou out. Alright, that pretty much was a 100% failure. Go back where it was. When the screw's good, you're good. Had it pretty good and I moved it. Put an indicator on there and really do it right. it started. Go with that. So there's how even it is, pretty even. And the nut's not wobbling around like it was. So you got both things pretty close now. I'll go ahead and trim it off. Boy, it looks real high. It is high. Better. Yep. So I'm checking for the center of the bit in the hole. So you look in the center of your bit, it should be in the center of the hole, which means you're on center with your cutting edge. You can see that or not. When you get it on center, it cuts better. Go that deep. Cut the chuck jaw. Alright, wait until I hit the jaw. So that's now thinned up as far as we're going to thin it. So the nut is now thinner than it was. We were 125 and 120, so now we are 96, 96, 92, 93. So we're fourth out of whack. Okay, so I'm going to put the cut edge goes against the washer. That. Nut's definitely tighter now because I squeezed it a little bit, kind of on purpose. Flat washer and our O-ring. Okay, our pack's a lot thinner now. Let's see what we got over here. Okay, I got a hard stop right there now. I can feel it stopping right here. We know when you tighten it, the threads are not flat, close to it. And you put a little torque on that sucker, straight across, and we still got a gap here. When we tighten this nut down, it'll pull all the way in. We're compressing the rubber right now. You can feel it. You can feel it compressing. Still compressing. It's hard to get this in here because there's no room. And somebody cut the nut way down. I don't know who that was. Okay, now we're getting tight. A little torque on that sucker and it's in there. Alright, so now that's officially jammed in there and tight. We want to make sure is that we have no leakage past the screw here. So we got a small cavity up here and a big cavity down here. So I'm not sure which one is. I think this is our overflow on our case. So we're pulling oil out of that. This should be our oil feed hole. And this one goes into the case and dumps into the primary. I'm assuming that's how it works. So looks like the taper screw is in there. I don't know if you can see in there, but can we maybe see? So either way, I don't want no liquid either going from this hole to this. You know, either way, between these two here, there should be no flow of liquid if it's sealed. So what I'm going to do is I'm going to put a little bit of liquid here in this orifice and see what it does. So I'm going to take a little bit of our spray here, like that. I'm going to run it down until it fills up the cavity. So we got cavity in there. There should be no liquid on the other side here. And nothing appears to be going through, and we got a full cavity of liquid in there, so I'm not seeing anything dripping through, which is a good thing. I don't have any real way of pressurizing that hole with air because it's not a flat surface. But the CRC is not bleeding through. So we'll let that sit here for a little while. Actually not right here. We'll do it over here on the table over here. Okay. We're over there now. Okay, so now we got the liquid right in here. You can see it's got liquid there. Oop, right there, and then as long as this hole stays dry in there, I'm happy. So I'm going to let that sit for a while. The other thing I got to do is I got to work on this cavity here to make a relief in here for a clip. So that's another project I got to do. And the problem is right now I'm doing a drip test over there, so I'm going to wait on that. We'll come back here a little bit and do that. I got to find some more parts to do that test anyway. Okay, I'm going to give this a few minutes and let it see if anything pokes through. Right now we're bone dry, which is exactly what I want to see. No fluid. Alright, let this sit for a little bit.